In this video, we're going to use prime factorization to work a few examples. So the first example says fill in the missing numbers in the following factor tree. Now notice that this factor tree has the factors, but we don't know this number up at the top. So that's what we're looking for. So we're basically going to be working this one backwards. So we're going to take the two bottom ones, 3 times 13, multiply them together, and I'll get 39. Then I keep working up the factor tree and multiply that 39 times 2, get 78. And then finally 2 times 78, and I get 156. So could we find that very top number without having to fill in the rest of these numbers? Yes, we definitely could. All you'd have to do is multiply the factors. Multiply those, the 2, the 3, and the 13. So now we're going to find the prime factorizations of the numbers in number 2. Now, notice that this doesn't have like a number like 597. They already have it factored for us, but it's not a prime factorization. So therefore, we've got to take the ones that aren't prime, the 4 and the 6 in this case, and factor them. So the factors of 4 are 2 and 2, and then the factors of 6 are 2 and 3. So we could just list all of those out and get 2 and 2 times 3 times 7. So that will be the prime factorization of that. So I'd like for you to do letter B and turn that in class. Now we have, and we could also, I forgot to mention this, we could also write that as 2 to the third times 3 times 7. So either way would be a correct answer. Now this last problem talks about Miss Arborita, and she is wanting to plant fruit trees in a rectangular array for each of the following numbers of trees. She wants us to find all the possible number of rows if each row is to have the same number of trees. So let's start off with, let's say I have 36 trees and we're just going to have one row. It would look like that. One row with 36 trees. Now, could we have 2 rows that have the same number of trees and only have 36 trees? Yeah, we could have 2 rows and there would be 18 trees in each row. We could have 3 rows and that would give us 12 trees in each row. We could have 4 rows and get 9 trees in each row. What about 5 rows? Could we use 5 rows and get 36 trees and no more and no less and have the same number of trees in each row? We couldn't with 5 because 5 doesn't go into 36 evenly. But 6 would. So 6 trees, 6 rows with 6 trees each. Then 7 wouldn't work, 8 wouldn't work, but we could have 9 rows with 4 trees. Are you starting to see a pattern? We could keep going. So you could think of it like this. Here are the factors of 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, 9 and 4. Notice that the ones in red that I've highlighted, those are the number of rows. So, to answer the question, the number of rows for Miss Arborita to have 36 trees and the same number of trees in each row would be those, basically the factors of 36. So what I would like for you to do to turn in to class tomorrow or the next time I see you is B. I want you to figure out how many rows Miss Arborita could have if she had 28 trees, and then what if she had 17 trees?